All right, let's just dive right into this. Welcome to today's explainer. We are going to be completely rebuilding your software development tech stack for the year 2026. We are rapidly moving out of the era of manual coding and stepping into a reality where your primary job is, well, something entirely different. We're going to build out this ultimate developer toolkit, layer by layer, and I promise you, by the time we wrap up, how you view your daily workflow is going to fundamentally change. So I want to hook you right off the bat with a realization from the source material that is honestly kind of wild. Listen to this quote from Ryan Lapapolo over at OpenAI. Implementation is no longer the scarce resource of what it means to do the job of software engineering. Code is free. I mean, just let that sink in for a second. For decades, literally decades, the massive bottleneck in software development was human implementation. Fingers on keyboards, hunting down that one missing semicolon for hours. Today, autonomous agents can generate, refactor, or delete thousands of lines of code in seconds. The bottleneck just isn't typing anymore. So if code is free, what exactly are we getting paid to do?
To answer that, here's our agenda for rebuilding your workflow. 1. The AI-Native IDE revolution. 2. Terminal agents like Claude Code. 3. MCP, AI's universal port. 4. AI-powered security platforms. And 5. The rise of context engineering. Let's get into it.
Starting with number 1, the AI-Native IDE revolution.
Think about the foundational layer where you spend most of your time. We're totally moving away from the old way of doing things. Reactive code completion, basic syntax highlighting, and that intensely manual debugging process. Instead, the 2026 way is all about deep repository context. It's about AI orchestrating multi-file agentic edits and proactive workflows. You aren't just writing boilerplate anymore. You are orchestrating the entire software development lifecycle through a single, cohesive AI interface. It's a massive shift.
Let's see how this actually builds out in practice with the two massive players in this space right now. First up, we have Cursor. It's a VS Code fork, and it features something called Composer. If you've ever spent hours doing a mind-numbing refactor of variable names across 20 different files and hated every minute of it, well, Composer lets you just describe those changes in natural language, and boom, it edits multiple files at once. Cursor also has BugBot, which is an agent that automatically scans pull requests in the background for really subtle logic bugs. Then, on the other hand, we have Windsurf. Windsurf uses a feature called Cascade to create a proactive AI workflow. It actually anticipates what you need next, flowing alongside your coding rather than just awkwardly taking over. Plus, both tools have shifted toward predictable credit costs, with Windsurf utilizing the SWE1 model. These aren't just glorified autocorrects, they are proactive, codebase-aware partners.
Moving to Section 2, Terminal Agents, specifically looking at Claude Code.
Okay, so we're stepping out of the graphical interface and straight into the command line. A recent analysis by William Blair really brilliantly illustrates the mechanics happening behind the scenes here. When a user submits a query, the assistant doesn't just blindly start typing. Step 1 is prompt analysis. Step 2 is context search, meaning the model looks at your previous queries and the overall context of your software project. Step 3 involves mapping all of that against internal representations to match the correct coding structure. And finally, in Step 4, the model generates and intelligently pieces together code snippets before finalizing its output. It's this deep context awareness that allows terminal agents to execute really complex tasks completely autonomously. But here's the catch, right? How do you prevent an autonomous agent from just going completely off the rails? Well, you implement the Research Plan Implement Loop, or RPI. Terminal agents like Claude Code rely heavily on this structured workflow. First, they research. They actually navigate your codebase to understand how the system works and write an objective document. Second, they plan. They outline exact implementation steps, specific file names, and explicit testing procedures. Only after all that do they move to Step 3, implement. Here, they execute the plan, step by step, using a perfectly clean context window. This structured workflow is exactly what allows agents to safely handle complex, multi-step tasks, like, say, add authentication to this API, without you needing to hold their hand the entire time. Now for Section 3, MCP, AI's universal port. So how do these intelligent agents actually talk to your databases, your Slack, or your Jira? That is where the Model Context Protocol, or MCP, comes into play. It is the crucial connective tissue uniting all these disparate tools. Think of MCP as a universal USB-C port for AI. It's a great metaphor. Before MCP, if you wanted an agent to talk to a database or a CRM, you literally had to write a custom parser and integration for every single tool. It was a catastrophic, headache-inducing fragmentation crisis.
MCP finally solves this. It completely decouples client applications, like Cursor or Claude Code, from the underlying tools and data sources. It standardizes the connection and ensures secure, consistent data access across entirely different platforms. Honestly, what a massive relief for developers. And if you're wondering if this protocol is actually catching on in the real world, the adoption numbers are just staggering. 110 million. That is the number of monthly SDK downloads for MCP across supported languages. It is, without a doubt, the definitive standard for unifying agent tooling in 2026.
Section 4. AI-powered security platforms.
With all these autonomous agents writing and shipping code at absolutely breakneck speeds, we've got a brand new problem on our hands, and we absolutely need a modernized security safety net to catch it. We essentially need protection at two distinct phases. On one hand, you have platforms like Snyk governing AI-generated code right at the source. Snyk integrates directly into the developer workflow to enforce proactive AI governance and actually track agent usage as it happens. On the other hand, you have platforms like Raven operating an application detection response, or ADR, system. Raven monitors live runtime behaviors to catch those sneaky, malicious deviations that might somehow slip through into the live application environment. You need that protection at the moment the code is written, and again at the moment the code is executed. Let's quickly summarize how these distinct platforms keep all this speed from completely compromising our safety. Snyk tracks agent usage and feeds security context directly back to your coding tools via MCP. Then you have CodeRabbit, which has really become the category-defining platform for AI-powered, incredibly codebase-aware pull request reviews. Meanwhile, Raven's ADR prevents malicious runtime deviations, which is huge because it protects your apps even if a known CVE doesn't exist for the vulnerability yet. And finally, there's Convu, which leverages AI right alongside reachability analysis to drastically reduce those incredibly annoying false positive alerts that have historically plagued security teams. It's a really comprehensive security layer. And finally, Section 5, the rise of context engineering. This right here is the most critical human philosophy you have to adopt to manage this entire 2026 tech stack. But to understand context engineering, you first have to understand the enemy. And that enemy is context rot. Context rot is this phenomenon where a model's ability to accurately recall information actively declines as the number of tokens in its context window grows. See, you might think the magic solution to AI coding is to just dump your entire massive codebase into an LLM and say, hey, fix this bug. But when you do that, the model enters what engineers affectionately call the dumb zone. It loses its attention budget, the computation costs absolutely skyrocket, and it starts hallucinating logic that makes absolutely zero sense. So, because of context rot, you have to explicitly engineer and isolate your context. The industry has basically developed a DevOps-inspired loop for this, known as the Context Development Lifecycle, or CDLC. It breaks down into 4 steps. Step 1 is generate. This is where you take that implicit engineering knowledge out of your brain and convert it into explicit rules, schemas, and MCP servers for the agent. Step 2 is evaluate. You run probabilistic evaluations to see if the agent actually succeeds against a set error budget. Step 3 is distribute, managing these context packages just like you would software packages, complete with strict version control and security scanning. And step 4 is observe, constantly monitoring your agents in production to detect any prompt drift or token inefficiency. Ultimately, what context engineering does is orchestrate external information and tools around LLMs to deliver consistent, accurate, and highly domain-specific AI results. It's all about curating the absolute optimal, smallest possible set of high-signal tokens to hand over to your AI agent. In 2026, the competitive advantage doesn't belong to the developers who have access to the largest models. No, it belongs to those who can construct the most precise context environments. Context is literally the new code.
So I want to leave you with a final provocative thought to take away from this explainer today. Take a good look at your 2026 toolkit. If AI-native IDEs and terminal agents are the ones writing the code, and if tools like BugBot and CodeRabbit are the ones reviewing the code, and if platforms like Snyk and Raven are securing the code, what exactly are you engineering tomorrow? You aren't just a manual coder anymore. You are a context orchestrator. Your job now is to curate the environment, define the rules of the game, and guide these intelligent agents to success. Embrace these tools, master the context, and step confidently into the future of software development. Thanks so much for joining me.